Okay, this is going to be a much shorter video. I'm going to show you how you can go about using some of the tools that you've been learning with Greg and at a conference in terms of just pulling off that force in terms of knowing what its moment is. Remember, it's R cross F, R to the point of application, and F, R is a XYZ vector, the radial vector that points to the point of application, and the force is a delta XYZ. Realize this mathematically works even if you don't do this, but what you would first do is basically make sure that all your forces are applied so their tails are at the right spot. So I'm going to go here, go to an endpoint there, and push that down to the endpoint there. Now, if you are writing sums of the moments about this point here, you change your user coordinate system, UCS, and change its origin to there. And now if you just list that forced UCS, the origin is here, and right now if you do ID, the endpoint, you realize that obviously any force around there, but if you click on this and say list, you have its point here. In other words, you have the radial vector to the point of application, and then you have the force vector. This one, of course, ID, the endpoint there. You have the radial vector, and then the force vector is being 1. It gets better than that. As you notice, you can do CUI. You can go into CUI and change your tooltips. So I think it was rollover tips. Right, click to that, and boy, because we are in Civil 3D, we're not getting what we really want. So I'm not going to be able to show you here, but remember how you can change your rollover tips. I'm in Civil 3D at home. Hit cancel here. Remember how you can change, you can just change your rollover tips. You can change your quick property options. You can go here, what you want on. The ability to change what your quick property tips is possible as well. But I guess I'll just leave it at the list. L-I-S-T. In other words, you can know that the radial vector is 12.33, 0 and 0, and the force vector is 5.1 minus 4.38 and 0. And then if you want to do it from the other support, you just change your UCS. Your new UCS is now from the endpoint there. And now when you list this vector, you have its radial vector back. And you can do the same thing here. So by doing that very, very quickly, you can pull off and use that R cross F. Let's just see if we can remember how easy it is to do a cross product. Remember, 1, 2, 3 across, 1, 2, 3 back, and when you're not in 3 dimensions, it becomes relatively straightforward. That's something that you should have mastered in your calculator, probably best done by having a list called RX, RY, RZ, RM for radial magnitude, FX, FY, FZ, FM for force magnitude, MX, MY, MZ, MM for moment magnitude, and then doing some very straightforward calculations that align with your cross products to have the calculator calculate between the lists. You don't necessarily need to do that. You should be able to very quickly be able to do these type of problems. I'll go to a more complex one now. I will go to perhaps problem 7 here. If you remember this one, this is I was showing you basically how you can add these vectors together and in terms of their moments of, their points of application. But I'm going to go ahead and that one's still there. Get this here. Once again, you don't even need to, in all reality, mathematically shift these down so they're hanging, their point of application is there. So you really, it does work this way. The moment, because we know the moment of the force of any force along the line of force is the same, you could just do this. UCS, new, your endpoint there. And then you could just list one force and use R cross F. So he's calling its point of application. What it's not is 10, 8.33. The force is 0 minus 5. You could do a cross product on that one. You can do a cross product on this one. Remember the from point. That's why drafting in the right direction is oh so important. And again, that one, we got an ID that is terms 15 and it's going straight up. You can then change the UCS, new, from the end point. You don't want the end zone point, you want the insert. In terms of these blocks have an insertion point right there. Now, once again, if you list, and we'll point out in school to do how to do the tooltips, right there you have its radial vector and its force vector. So that's really probably, if you can learn to run your calculator just slightly remotely, you should be able to do a series of moments on it and a series of 2D and 3D force problems. It's much more efficient, even I dare say, than Wolfram Alpha. So that's the third path to solving these equations. Thanks for listening.